Hey everyone, welcome to our next video. This one is the only section in chapter 3 that we do. So this is 3.1 and it is quadratic functions and applications. Now we won't worry too much about the applications in this section. Something to kind of know is some of these sections, when they say applications, we do a little bit maybe, but not much, partially because maybe the applications are kind of in a different class. So for instance, in Math 125, we do some quadratic applications in there. So for those of you who may be taking that class, that's where you'll see some more word problems and stuff for this section. So in general, we're going to be dealing with quadratic functions. Now, when we have quadratic functions, there are different forms that we could see the quadratic in. So we have standard form, which we have already seen is y equals, or f of x equals, ax squared plus bx plus c. So that is your standard form for a quadratic function. Let me go ahead and make my screen big. There we go. Our other form that we'll see is vertex form. Vertex form looks like this. Y equals A. Technically, this would be x minus h squared plus k. Now, sometimes you can maybe see a b in front of that x. We won't see that in our section because, well, we would factor out the b if we needed to. And so when you're in vertex form, we've actually already dealt with quadratics a little bit already and seen vertex form. So I'm going to scroll up just for a moment to kind of show you what I'm talking about. Here we go. Nope, just kidding. Where was it? Before that, stuff like this. So like part C, that was vertex form. If you look at part B, that was vertex form. And so something cool about vertex form is the vertex is very easily visible. So for instance, if we look at this old example we did, this is part C from an example in, I believe that was, sorry, I'm yawning, 2.6. 2.6. Example 2, part C. So if we look at this one, you can see the vertex in there. If we look at part B, it's a little bit more visible because there is no B value, so I would rather work with this one. This form right here, let me use yellow. This form here, that's basically vertex form. It's just that I have replaced C with H and I've replaced D with K, and we're not worried about the B right now. You'll also notice that I used to say stuff like, whatever makes the inside 0, that's your first point. And it also so happened that that was the vertex point. So let me go ahead to our new notes and I'll write some of this out for you in a more eloquent way. So when you're in vertex form, your vertex is the point h comma k. So let's look at a little bit of an example. So example 1, I'll say identify the vertex. And we'll do part A. I'll do f of x equals 2x plus 3 squared plus 1. And then B, let's do y equals negative 8x minus 4 squared minus 3. I don't know. I'm just making stuff up. So you want to compare it to our vertex form here. So my h in this case is going to be negative 3. Be careful. It's a lot like with the circles. So if you compare this to the formula, what you're really seeing is x minus negative 3. So when you write your vertex, it's going to be negative 3 comma, and then it would be plus 1, so positive 1. And so when we talk about the vertex is like that first point that we would want to plot. It's the point right down the middle of our parabola. So let me write that in here. Parabola. We should already know that quadratics are parabolas, but just in case. The vertex being HK. Vertex is like the most important point, really, on a parabola. It's always going to be our first point to graph. For part B, my vertex, you should do it on your own, but it would be 4, negative 3. So that's just looking at vertex form. Now, if we start with standard form, and we want vertex form, we need to complete the square. So if you start with your standard form, so a reminder, that's this one, and you want vertex form, you will have to complete the square. So I would like to do an example of completing the square with these. So let's see. I don't really like the example I have written in here. I feel like it's a little hard, so I think I'm going to start with one maybe a little bit easier. I keep like zooming in and out. Okay, there we go. Sorry. This would be example 2, and I'm going to say rewrite in vertex form by completing the square. And we'll do a few of these. So part A, let's do f of x equals x squared minus 10x plus 3. And of course I'll do more, but we'll kind of just start there. So first I want to remind you of the form we're trying to get to. We're trying to make this look like f of x equals a x minus h squared plus k. I mean, we're not guaranteed to have an a value or anything, but if we're supposed to have one, we would have one. In this case, we do not have an a value because we don't have anything in front of the x squared. Well, we do, but it's a 1, so it doesn't really... it doesn't really, I don't want to say it doesn't count, but the a value being 1 doesn't really do much to our graph or anything. Now, whenever you complete the square for this, I am going to do it a little bit differently than how I did it in the past. And the only reason is because usually we would have moved that 3 over to the other side. If we do that here, we might get a little confused and forget to bring it back. You might start solving for x and not actually just rearranging the problem. So I don't really want to move anything to the other side. What I will do is I'll just leave a space here. And I'll say that I do want to add something else right there so that I could make this factorable. Now, when we add something right there, we'll also have to subtract the same number to make sure that we are balanced. Kind of the same as adding it to both sides, but I'm only working with one side. So you always do b over 2 and then squared to figure out what you would need to add. So this is negative 5 squared, so 25. So I'm going to add 25 right here. Now, usually in our problems earlier when we completed the square in 1.4, I would have said, okay, also add 25 to the other side. The problem with doing that is I'm not trying to mess up the y side. I want it to stay as just y or f of x. But what I can do instead is I can say I also want to subtract 25 from the same side. So basically what I'm doing here is I'm just adding 0. If I add 25 and subtract 25 at the same time, I'm not doing anything. I'm just adding 0. But it'll allow me to factor this little piece right here. So now I'm going to factor that into x minus 5 squared. And then the positive 3 minus 25 would leave me with negative 22. And so this is vertex form. Let's do another one. This one is going to have an a value with it. So this one's very similar to the last one we did. So let me do f of x equals 2x squared minus, we'll do 20x. Let's do a plus actually, plus 20x. And then I'm going to go ahead and say plus 5. Again, I'm just kind of making something up. Now this one can be a little tricky because the first thing we need to do is we need to factor out the a value. Now I don't want to factor it out from the whole thing. I'm just going to factor it out from the stuff with x. The reason is because that 5 is only going to affect the k value at the end. So I'm just kind of going to write it off to the end. So I have f of x equals, I can factor out a 2. I'm left with x squared plus 10x. I'm going to leave a space here so that I can add something in. And then I'm just going to keep this 5 outside. So this might be a little bit of a weird concept to you that we're only factoring the 2 out of the terms with x, but we don't have to factor it out of the whole thing. I can just keep the 5 off to the side. Now to figure out what I need to add, I'll take my b divided by 2 and then square it. So 5 squared is 25. So I want to add 25 here, but be careful. If we add 25, we also need to subtract 25. Again, this part might look a little weird. This is the piece that I want to factor. So I'm actually going to get this 25 here outside of these parentheses. To do that, I would have to multiply this 2 by the 25, and then it wouldn't be in the parentheses anymore. So I'm going to write down what I'm doing. I have 2x squared plus 10x plus 25. Now that minus 25, if I do 2 times it, I get negative 50. And I still have this plus 5 on the outside. This is equal to f of x. Now I can factor those parentheses. So I'm left with x plus 5 squared. And then negative 50 plus 5 will leave me with negative 45. And this is vertex form. Now I am kind of curious to know what y'all thought of that. I really do think that this part, this step to this step, may be a little weird. Let's do another one. This one says f of x equals negative 2x squared minus 4x plus 3. Now again, I have an a value, which means I need to factor it out to the front. I'm going to leave myself a space, and I just have this plus 3 kind of hanging out. It's not being it's not having a 2 factored out of it. You'll also notice that since my a was negative 2, I factored out a negative 2. Okay, so now I need to figure out what I need to add. So I'll take my b divided by 2 squared, so that's 1 squared, so 1. So I'm going to add 1 and also subtract 1 at the same time. I don't want the minus 1 in the parentheses anymore, so I'm going to go ahead and multiply it by that negative 2 so that it can come out. So that would give me plus 2, and then I have plus 3. Factoring my parentheses leaves me with x plus 1 squared, and then I have plus 5 on the outside. So this is vertex form. Okay. Of course, I'm curious to know what y'all think about it, but I will say that if I ask you to do this to complete the square to find vertex form, you'll definitely only see one of them. And then later I am going to show you if you don't want to move to vertex form. Like how can you just work with a quadratic when you're still in standard form? You don't have to change it. Now for my next example, so this will be example 3, I'm going to work with that last quadratic we did. So I'm going to say graph the following. And complete the table. And so what I mean by complete the table is I'm going to ask you a bunch of questions. So for part A, I'm going to do f of x. I'm going to do the last one we just did. Negative 2x plus 1 squared plus 5. And I'm going to ask you just a bunch of questions about this. So first, I want to know the vertex. I want to know the domain. I want to know the range. I want to know if it's opening up or down. So that's kind of going back to transformations. I want to know where it is increasing, decreasing. I want to know the x-intercepts, the y-intercepts, and the last thing I'm going to ask is the axis of symmetry. So a bunch of information here, and I want to know everything. And then we will also graph it as well. So let's do our vertex first. So our vertex for this, try to fill out anything you can by yourself. I'll talk to you about it first. So vertex, we need HK. Domain, I think y'all can find the domain for this. Range, I usually like to do range after I graph, so that's fine if you want to do that. Opening up or down, that's going to be based on the A value, so it's coming back from transformations. Increasing and decreasing, we talked about that in 2.7, how to tell when a graph is increasing or decreasing. X-intercepts, we talked about in 2. Can't remember exactly when that was. Was that 2.3, I believe? X-intercepts are when the y equals 0. Y-intercepts are when the x equals 0. And then this last one we actually haven't talked about, the axis of symmetry. So we'll get there. But a lot of this I do believe you could do on your own. For my vertex, it's -1, 5. My domain is -infinity to infinity. For opening up or down, this is going to open down because I have a negative a value. So that means it has flipped over the y-axis. Or sorry, x-axis. Flipped over the x-axis. Flipped downwards, so I was thinking like y direction, but x-axis. Increasing, decreasing, we can wait for that one until we graph. X-intercepts and y-intercepts. So x-intercepts are when y equals 0. Y-intercepts are when x equals 0. And so I can go find those really quick. So for my x-intercepts, I have the y value or the f of x value equal to 0. So I get 0 equals -2 x plus 1 squared plus 5. So I'll solve this. So I get -5 equals -2 x plus 1 squared. Divide by -2, so that's going to give me 5 over 2 equals x plus 1 squared. Square root both sides, so I get square root 5 over 2 equals x plus 1. Move the 1 over. Be careful, this is plus or minus. -1 plus or minus square root 5 over 2 is equal to my x. So my x-intercepts are the points negative 1 minus root 5 over 2, comma 0, and negative 1 plus root 5 over 2, comma 0. For my y-intercepts, that's when the x value equals 0. So it's f of 0. So I get negative 2, 0 plus 1 squared plus 5. Negative 2 times 1 squared plus 5. Negative 2 times 1 plus 5. So that's going to be 3. So this point is 0, comma 3. And so let's go ahead and graph what we have. So I have the vertex is negative 1, 5. So that's pretty far up here. The other points that I've gotten, I have these two x-intercepts. Okay, they're ugly. They're really ugly to work with. But pay attention to what it's saying. It's saying negative 1 minus, and then I don't know, that's just some kind of fraction. 5 over 2, so that's roughly like 2.5, and then the square root of that, so really small. So it means that it's not going very far. So although I may not actually plot them, it's good to just know roughly where they're at. Now my y-intercept I can actually plot is 0, 3. So my graph probably looks something like this. Probably a little bit over further. The point is I'm looking for a sketch. I'm not looking for anything perfect. Those the x-intercepts that we have, I'm not graphing them perfectly on there, and I'm not worried about graphing them perfectly on there. I'm just getting a little bit of a sketch, at least knowing that the x-intercepts are real values, meaning they don't have I in them. That told me that it should cross the x-axis. And so there we go, we already have a graph. Now we just got to finish the rest of it. So our graph, our range, goes from negative infinity, and then the highest point is 4. So that's negative infinity to 4, bracket on that 4. When we talk about increasing and decreasing, we're talking about where does it look like it's going up, and where does it look like it's going down. So it looks like it's going positive slope on the left side. So that is from negative infinity to 1 is that x value. And it looks like I'm going downward, so a negative slope after that 1. So that's going to be 1 to infinity. And the 1 is included. Oh, sorry, I'm meaning to say negative 1. There we go. And then the last thing is the axis of symmetry. And I know we haven't talked about that yet, but the axis of symmetry is this invisible line that goes right down the middle. It's always the x equals of your vertex. It's a line, so that's why it needs to say x equals. I'm not going to take it if you just say negative 1, because that doesn't tell me anything. It's the line, x equals -1. It's a vertical line that goes right down the middle of your parabola. And so this one was a bit ugly to work with, but that's okay. Sometimes they're like that. Now, because we've already kind of worked with the vertex form a little bit in a previous section, I'm debating on whether I want to work with it more or not. Sorry, I'm just thinking. I have another example. But I'm just kind of thinking. Yeah, I think let's do one more with the vertex form. So part B, we're going to do y equals -x² minus 2x plus 3. Now I'm going to go ahead and turn this into vertex form. First. So to do that, I'm first going to factor out a -1 since I have an a value. I'm left with x² plus 2x. Leave myself a gap, plus 3. I'm going to add in +1 minus 1. Keep going. I get x² plus 2x plus 1. This would be a +1 plus 3 to take it out of those parentheses. I get -1 x plus 1 squared plus 4. So there's my graph that I want to work with for this one. And I'm going to find everything that I did on the last one. So I'm going to do vertex, domain, range, how is it opening, what else did I look for? I'm already forgetting. Increasing, decreasing. We'll do x-intercepts, y-intercepts, axis of symmetry, abbreviating just a little bit. I think that's it. I think that's all I asked for the last one. And so while you're watching this, you should go ahead and try to do this one completely on your own and just see how far you can get. Even if you get kind of stuck, it's still good to try it out just to see like, okay, I'm doing this on a test. What am I going to write to get partial credit? Like what am I going to try? And of course, I'll do it as well. So vertex for this one would be -1, 4. Domain, -infinity to infinity. Range, I like to do later. It's going to open downwards. Now because it's opening down, I already can do the increasing, decreasing, but we'll wait on it. My x-intercepts and y-intercepts, let me go get those. So my x-intercepts happen when y equals 0, so I get 0 equals -1, x plus 1 squared plus 4. Subtract 4. divide by -1, take the square root, so that's going to give me plus or minus root 4 equals x plus 1. So that gives me plus or minus 2. So when I subtract the 1 from the other side, I get -1 plus or minus 2 equals x. Well, -1 minus 2 is -3. -1 plus 2 would be 1. So for my x-intercepts, I get the point -3, 0, and 1, 0. Remember, the y value is 0, and I'm writing them as points. So this one's a bit nicer because we're actually going to be able to plot it a little bit better. Then I can go get my y-intercept. Now that happens when x equals 0, so y equals -1, 0 plus 1 squared plus 4, -1 times 1 squared plus 4, -1 plus 4, so that's going to give me 3. So this is the point 0, 3. My axis of symmetry is always x equals, and then it's the x of the vertex, because that's right in the middle of the graph. And now I will go ahead and graph 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So for my vertex, -1, 4, so that's going to be up here. My y-intercept is 0, 3, so here. My x-intercepts, I have -3, 0, and 1, 0. So my graph is looking like this. So this one's a little different from how we graphed earlier, because earlier we had to kind of guess what x values and stuff we wanted. This time we're kind of just using our main points, x-intercepts, y-intercepts, vertex. Now if you wanted more points, you could always plug in some x values and just see what you get. There's no shame in doing that. The range for this graph is -infinity to 4. Hey, I made a mistake on the last one, and I didn't realize it until I wrote 4 right here. I'll come back to it in a second. It's increasing on the left side, so that is from -infinity to -1. Decreasing on the right side, so that's -1 to infinity. And so that's it. Now I want to come back up to the top here on problem A. And you might have noticed it, and I always think it's funny, like, to think about if y'all notice a mistake that I've made, if you're like yelling at me through the video or not. I messed up my range. I don't know why, but I put 4. The highest y value is 5, right? The vertex goes up to 5. So that should be the height of my graph, my range. Sorry about that. I have no idea what I was thinking when I wrote 4 on there. Who knows? Sorry about that again. It's a little late, but that's really no excuse. Okay, let's now talk about what if we do not want to move to vertex form. If you don't want to move to vertex form, you can use standard form. To get your vertex. Here's what it'll look like. Your vertex is negative b over 2a, comma, f of negative b over 2a. The negative b over 2a comes from the quadratic formula. But what this is saying is that the x value of your vertex is your negative b over 2a. And then to find the y value of your vertex, you would just plug in that x value into the parabola to solve for the y. Of course, let me do an example. So this is number 4. I'll just say find the vertex. Part A, we'll do the one that we just did. Just so I can show you like what it would have looked like if we didn't do it the other way. And we'll do another one, just finding vertex. And this one, let's just make it up. Let's do y equals 2x squared minus 3x plus 8. So for our first one, you want to identify your A is -1, your B is -2, your C is 3. You don't need the C, but I just did it. So the X value of my vertex, so let me write it like this. I like to write vertex X, and that is equal to negative B over 2A. So it'll give me -2 over 2 times -1. So 2 over -2, which is -1. So that's the x of my vertex. Now for the y, I'm just going to plug that x back in. So f of -1 would be -1 squared minus 2 times -1 plus 3. You get -1 plus 2 plus 3, which is 4. So my vertex is -1 comma 4. And this is the same one we did earlier. So maybe using this will be a little bit easier for you than actually having to complete the square and all that good stuff. Part B, of course, you should do on your own. That way you have some practice. My A is 2, my B is -3, and I don't need the C. For my X, it's negative B over 2A, so I get -3 over 2 times 2, so that's going to be 3 over 4. Oh no, I did one with fractions. That's what I get for making up an example. Sorry. For the y, we just plug in that x, so I get 2 times 3 over 4 squared minus 3 times 3 over 4 plus 8. Now, I try not to give y'all stuff that looks this ugly, but we'll do it just to do it. So this is 2 times 9 over 16 minus 9 over 4 plus 8. I'm just simplifying here. 2 over 16 can simplify to 9 over 8 here. Minus 9 over 4 plus 8. Now I want everything to have the same denominator, so I can get everything to have a denominator of 8 and do 2 over 2, and this one I do 8 over 8. I get 9 over 8 minus 18 over 8 plus 64 over 8. Coming up here for space. 9 minus 18 is going to give me negative 9 over 8 plus 64 over 8. 64 minus 9 will give me 55 over 8. So my vertex here, and I apologize if I made a mistake somewhere in there. I hope I didn't, but I did just make this one up. So 3 over 4 was my x, 55 over 8 was my y. And again, I really try not to give you ugly ones like that on the test. But maybe sometimes looking at ugly ones is what we need. Alrighty, I have one more example for us, and this will be a whole graphing one. So example 5, we'll graph and fill out all of our info. I'll just say info that we needed. So here's our function. We're going to do f of x is equal to 3x squared minus 4x plus 3. And we'll find all the same information as before. It's just now we're going to do it with standard form. So I have my vertex, I'll do my domain, range. I already forgot everything that I asked for. Domain, range, how is it opening? So is it like up or down? Increasing, decreasing, x-intercepts, y-intercepts, and axis of symmetry. So everything we did before, but this one we're just going to leave in standard form. I'm not going to worry about completing the square. This is a good example of one that I would not, personally, I would not even want to move it into vertex form, because if I had to factor out this 3, I end up with all kind of ugly fractions, and it's just not looking good. So I don't even want to move this into vertex form. So first for my vertex, let's go get that first. So the x is negative b over 2a. So this will be negative, negative 4 over. And I know I keep picking b's that are negative. It's just sometimes it happens that way. 2 times 3. Is this another fraction? Oh my gosh. 4 over 6. So this would be 2 over 3. Did I really pick another one that's ugly? Well, it is what it is. Sometimes they're ugly. Now for the y for my vertex, I'm plugging in that x value. So I get 3, 2 over 3 squared minus 4 times 2 over 3 plus 3. Simplifying, so this is going to give me 4 over 9 minus 8 over 3 plus 3. Oh, this one's not as bad. 3 over 9 simplifies to 4 over 3 here, minus 8 over 3, plus, and that 3 I can make into 9 over 3. Four over 3 minus 8 over 3 would be negative 4 over 3 plus 9 over 3. So I get 5 over 3. So for my vertex, I get 2 over 3, comma, 5 over 3. My domain is negative infinity to infinity. My range, don't know just yet. I like to graph it first. It's opening, so my a value is a positive a, so that means it's going to open upwards. Increasing, decreasing. So if it's opening upwards, that means it looks something like this. So my increasing is going to be on the right. My decreasing is going to be on the left. So we can keep that in mind. And the point at which it's going to be changing is that vertex point. My x-intercepts and y-intercept, let's go get those. My x-intercepts. So remember, x-intercepts happen when the y equals 0. So that's 0 equals 3x squared minus 4x plus 3. We can try to factor this. I do not believe that it factors. So we will have to try something else. In that case, you can try completing the square. I don't think it's helpful on this one, so I'm just going to use quadratic formula. So I want to remind you of that. Negative b plus or minus the square root b squared minus 4ac all over 2a. So I get negative negative 4 plus or minus the square root negative 4 squared minus 4 times 3 times 3 all over 2 times 3. Positive 4 plus or minus, I get 16 minus, that'd be 12 times 3, which is 36, divided by 6. All right, this is giving me an imaginary value, which is fine. Negative 20 over 6. Four plus or minus, this would be 2i root 5 over 6, which simplifies to 2 plus or minus I root 5 over 3. Cool. This means that we do not have x-intercepts. So I would say we have none that are real. We do not have x-intercepts. X-intercepts are defined as real points where the y value equals 0. So we do not have any. And that's all right. We'll see what it means for our graph. For my y-intercepts, I'll do that up here. My y-intercept happens when my x equals 0, so I'm just going to plug 0 in here. For this, I just get 3. So this is the point, 0, 3. That's so funny that all of them have ended up to be 3. My axis of symmetry is always x equals and the x of my vertex. And now let's go ahead and graph. I'll draw my graph right here. I know I'm not being very organized right now. Two over 3. Well, I know it's smaller than 1. 5 over 3. Just a little bit bigger than 1. So my point here is going to look something like about right here. 2 over 3 is about 0.6 or so. And then 5 over 3 is about 1.6. And then it's facing upwards. So that's good to know. My y-intercept is at 0, 3. So here's what my parabola looks like. Something like that. And so that's why we didn't have any x-intercepts, because it's pointing upwards, so it never crosses the x-axis. So it makes sense that we got imaginary ones, because we don't have any. My range, I'm starting at the y value of my vertex. So that's going to be 5 over 3. And then I go up, up, all the way to infinity. I'm increasing on the right side of my graph. So that's going to be from 2 over 3 to infinity. I'm decreasing on the left. So that's negative infinity to 2 over 3. And that's it. And my axis of symmetry would have been right down the middle. So really the only difference here was we solved our x-intercepts a little bit differently. And those can be solved many different ways. If we're already in vertex form, we're basically going to use the square root method. If we're in standard form, we could have tried to factor, complete the square, or quadratic formula. In this case, we had to use quadratic formula. The vertex we found a little differently from vertex form to standard form. Y-intercept is always plug in 0 in as the x. So my hope is that this section was all right for you. If not, as always, please reach out to me and I would love to help you out. But overall, I hope y'all have a wonderful day and I will see you in our next video.